a comprehensive guide to HPLC. Warning: this video includes everything you need to know about HPLC. Once you watch this video, you'll be dying to know the next series. As a series of comprehensive guides to HPLC, we're going to take HPLC Basic Part 2 to know all about HPLC pumps. Let's start with what an HPLC pump is. An HPLC pump is a solvent delivery module that draws the mobile phase from solvent bottles at the specified flow rate with composition to deliver the sample to the column. Modern pumps are configured with at least one pair of pump heads, including reciprocating pistons, and there are check valves on the pump head which allow the mobile phase to flow in one direction, not in a reverse way. HPLC pumps can be classified into two major types, which are serial and parallel, depending on their mechanism. Let's see how the pump head in serial works. When a piston of the primary pump head is pulled out to draw the mobile phase, the pump head is filled with the mobile phase. And when the primary piston pushes the mobile phase, the half of mobile phase flows out to the system and the rest will be filled in the secondary pump. The secondary piston pushes the rest of the mobile phase into the system, while the primary piston is pulling out the mobile phase to fill the primary pump head. Although pump heads in serial have only one pair of check valves, the primary piston needs to run twice the operation cycles to refill the secondary pump head, which makes the workload twice and results in the wear of parts such as check valves and piston seals. In a parallel pump, both pistons independently work to draw the mobile phase, in turn, to deliver it at a programmed flow rate. Although the parallel pump requires two pairs of check valves, it delivers pulsation-free flow that can reduce the wear on the consumable parts. The pump operation mode can be categorized into isocratic mode and gradient mode, depending on mobile phase mixing. In isocratic mode, there is no change in mobile phase mixing rate during the analysis, and it's recommended for the simple application that needs to analyze one or two analytes. Due to the constant composition rate of mobile phases, it provides superior results in repeatability. Mostly, one mobile phase eluting line is used from the pre-mixed solvent in one bottle. This pump is called an isocratic pump that has one pair of pump heads with a single solvent line. In gradient mode, the mobile phase mixing rate is varied during the analysis, and it's recommended for the application that needs to analyze more than two analytes. Because the mobile phase composition rate keeps changing for the optimized condition for each peak, the analysis time gets decreased and the peak shapes get sharper. And there are two gradient modes, which are low pressure gradient and high pressure gradient. In low pressure gradient mode, there is a gradient proportioning valve to draw the selected solvents at a programmed composition rate, and it is placed in front of a pair of the pump head. You can utilize up to 4 solvents for mobile phases, and the pump used in this mode is called a quaternary pump. In high pressure gradient mode, 2 pairs of pump heads are required to draw individual solvents, and the mixer is placed on the next pump heads. You can utilize up to 2 solvents for mobile phases, and the pump used in this mode is called a binary pump. This mode is mostly used in the need of high productivity or high resolution HPLC, UHPLC applications. There are a few things required for the selection of a good HPLC pump. An HPLC pump must provide a stable flow rate and pressure. To do this, it has to be a pulse elimination system, and all flow paths should be inert for use of various solvents usage. With the ease of use, all parts used in the pump should be endurable at high pressure, and the isocratic and gradient mode pump should be available. And there are some more things to be aware of when operating an HPLC pump. If you use the solvents with air bubbles, the flow fluctuation will occur, so does the poor repeatability. So, all solvents used for HPLC must be degassed. When the use of almost use-up solvents, the solvent will be empty sooner or later, and the air bubbles can be introduced to the HPLC system. So, you need to check whether the solvent is filled in the bottle before use. With the use of a buffer, there might be salts remaining on the surface where the solvents flow. So, you have to rinse fully the system with water after using a buffer. In the use of more than 2 mobile phases, you should check whether those solvents are fully miscible enough for a stable flow rate. Other than these, pump priming should be performed before use, and you have to monitor the pump pressure carefully during analysis. Want to learn more about chromatography? Please stay tuned on Young & Chroma's channel.